Today we are discussing adding and subtracting rational numbers, any kind of rational numbers that we can mix together. A recommendation for when you are adding and subtracting, because fraction adding requires a common denominator. I recommend using decimals to add. There is one exception to that, and that is when you have a repeating decimal. Those will not work because you would have to round as opposed to having an exact answer. So when you don't have repeating decimals, you should use decimals to add. But remember that if you have to use fractions or you choose to use fractions, remember that that requires a common denominator. Okay? Our first example is 3 1/2 minus 4 7/10. So remember I mentioned using decimals to add or subtract. Well, in this case we have 1/2. So to turn this into a fraction, or this fraction into a decimal, I'm going to take 1 divided by 2. 2 goes into 1 0 times. So I'm going to put my placeholder decimal and 0. 2 goes into 10 5 times, and I do not have a repeating decimal here. 1/2 is not a repeating decimal. Okay, so I have 3.5 minus 4.7. Because of the fact that this first rational number is smaller than the second, I'm going to use my keep, change method and think about my integer adding rules. Okay, so I have 3.5 minus 4.7. I'm going to say 3.5 plus negative 4.7. Keep, change, like I do with adding integers. Now, because of the fact that I have different signs, I'm going to subtract. So I'm going to say 4.7 minus 3.5. 0.7 minus 0.5 gives me a 2, and 4 minus 3 gives me a 1. The 4.7 is larger, so I'm going to keep my negative, and that will be my final answer is negative 1.2. Now let's say that I chose to find my answer in decimals, but I needed a fraction to answer the question appropriately based on whatever was asked. So I'm going to keep my negative, of course, and I'm going to remember that I have 1 and 2/10 if I read this properly. So I could say negative 1 and 2/10, but that does simplify to negative 1 and 1/5 as well. Remember, 2 and 10 can both be divided by 2 to get me that final answer of negative 1 and 1/5. But both of these, since they are the same value, would be appropriate answers to this problem. Our next example, we have 1/8 plus 8/10. So remember here we are dealing with adding and subtracting, in this case adding. So I recommend that we use decimals where possible. So 8 is not going to cause a repeating decimal, but we will double check this and make sure. When I divide 1 by 8, 8 does not go into 1 at all, of course. So I'm going to put my placeholder decimal and my placeholder 0. 8 goes into 10 exactly 1 time. And I still have a remainder, so I'm going to keep going for a minute here. 8 goes into 20 exactly 2 times. And 8 times 2 is 16. And I finally get a number that will simplify out. And 8 times 5 gives us 40. So my simplified decimal form is 125 thousandths. Now I'm adding, so I need to line up my decimals. So I'm going to just do that right away. Put a placeholder 0 here to line up our decimals. And I'm going to add down now that I have my decimal place lined up, right? So 0 plus 5 is 5, 0 plus 2 is 2, 8 plus 1 is 9, and then 0 plus 0 is 0. 925 thousandths. So again, I could write this as 925 thousandths also. Simplify this by 5. Now 925 divided by 5 is going to give us, we have 1. 42, we have 8, and we have 25, gives us 185 over, and 1,000 divided by 5 is going to be 0 to 100. Now I can still simplify this, so I'm going to simplify by 5 again. 185 divided by 5. Clear some space for myself. Now this isn't a crucial part to this. I already have my answer, 925 thousandths. But if I need my answer in fraction form, it is good to know what I am working with, and simplified fractions, especially when we're starting with thousandths as our denominator, can be a bit messy to work with, okay? So 5 into 1 is 0, 5 into 18 is 3, because I can get 15 in there. And 5 into 35 is 7, so I have 37 over, and 200 divided by 5 is 0 for 0. 37 40ths. My final example is going to be 1/3 minus 1 3/10. Now, in this problem, 1/3 is going to present a little bit of a challenge for us, because when I take 1 and divide it by 3, I get 0.33333, so on and so forth. It's 0.3 repeating. So I can't use a decimal in this case, because a decimal is not going to give us an accurate answer. If I start to subtract it 0.3 minus 1.3, I'm going to get a close but not 100% accurate answer. So in this case, I need to use fractions, okay? So I'm going to switch this 1 3/10 into a fraction form. I've been saying this number out loud, so I have 1 3/10. And when I'm subtracting, I am going to ideally work with common denominators, or I have to work with common denominators, but I'm ideally going to work with an improper fraction. So I'm going to use my little C method here. 10 times 1 gives me 10, plus 3 is 13/10, and it's being taken away from 1/3. My next order of business is to find a common denominator. Now I could list my 3's out, but my 10's are going to make my life a little easier. So I have 10 times 1 is 10. 10 times 2 is equal to 20. These are both not divisible by 3. 10 by 3 is equal to 30. And hey, it's a 3 there. So I'm going to adjust both of these fractions so that they have the same denominator of 30. And keep a consistent numerator with their original, so that way the value remains the same. So 1/3 to 30. I'm going to think about what I did here. So I did 3 times 10 gives me 30. So if I did that to the denominator, I do it to the numerator. Anytime I do anything to the bottom, do the same thing to the top. So 1 times 10 gives me 10. And down here, I multiplied this by 3. So I'm going to do the same thing to the numerator. 13 times 3. 3 times 3 is 9. 3 times 3 is 3. Sorry, 3 times 1 is 3. So I end up with 39 over 30. Now, this last part, we're going to keep change, because I am taking away a number that is bigger than the number with which I started. So, keep change. 30ths, plus negative 39 over 30. My answer will have that 30 because I keep my common denominator, of course. And I'm essentially taking 10 plus negative 39. 10 plus negative 39 is going to be subtraction because they have opposite signs. So essentially it's 39 minus 10. And 9 minus 0 is 9. 3 minus 1 is 2. I keep the sign of the larger number. I get negative 29 30ths. Now, similar to our original problem, 30ths, and especially this case with the 29, will end us with a repeating decimal, so I'm going to leave it in this format for our answer. One last thing I wanted to note was a handful of repeating decimal fractions. So there are an innumerable amount that you can come up with, but some really common ones that you will see will be denominators of 3, 6, 9, 12. So basically multiples of 3. Some of the multiples of 6 will simplify to 1/2, for example. The 12, the same thing. But the ones that are odd will work as repeating decimals. Okay? We also have 7. We have 11. We have 13. Basically, a lot of the prime numbers are going to end us with a repeating decimal that will go on forever and ever as well. So keep these in mind when you are working on a lot of the prime numbers, not all of them. But keep these in mind when you are working on turning a fraction into a decimal in order to combine it with another number. Because if I have a repeating decimal, I cannot be accurate. Happy practicing.